Okay, so this is going to be just full worked solutions to them 4 exam questions I gave you. Just going to do them in order as they came on the sheet. So if you only need question 3, just skip forwards, for example. So how have I got green and blue selected at the same time? Okay, let's make a start. So question 1. Well, we're finding the tangent, so we want to first do dy by dx. Then we want to sub in x equals 1 to get a gradient. And then, well, that will just tell us the gradient at the tangent. So then we need to find a y coordinate. That is going to be sub x equals 1 into y equals. So I should really put there what I'm subbing it into. And then number 4, we can do our y minus y1, x minus x1. So that's the 4 steps I'm going to do in my head. And then, I guess 5th step is rearrange to make it look like this, which is the horrible part, which I know a lot of you didn't like. Okay, you pretty much get a mark for each of them steps. 6 marks, a mark for each of these processes, and then your 6th mark for getting it right. So you can judge how far you got down. So first of all, let's just do dy by dx. I've got a bit of a smaller writing tablet, which I hate writing with, so my handwriting's not going to be super neat. This one, that just differentiates to 1 over x. And this, you differentiate the top and multiply by it. So minus times by minus 2 is going to be positive 2e to the minus 2x. Okay, so that's that. At x equals to 1, dy by dx is going to equal to, well, that's just 1 plus e to the power of minus 2, 2e to the power of minus 2, sorry. And then let's find the y coordinate. So, sorry, that's my gradient at the tangent. That is just a number, remember, because e is just like 2.4 something, or whatever it is. To find the y coordinate, we do x equals 1 into y equals to ln 3x minus all of that business. So y equals 2 ln 3 minus e to the power of minus 2. Again, that's just a number, but we're not going to put it in our calculator for decimals because we want to show that it's in a certain form. Generally with e's and lns it's better to just keep it in their e and ln form because the numbers are so awkward. Okay, so that was step 1, that was step 2, that was step 3. Next thing, I've got a coordinate pair, I've got a gradient, all at x equals 1. So step 4, I can do y minus y1 equals to m brackets x minus x1. Quite awkward, but no big deal, we can deal with it. Let's expand this bracket on the left first. Remember, minus times by all of these things, so all the signs are going to change. So that's going to be minus ln 3, that is going to be positive e to the power of minus 2. Equals 2, we've got some double bracket expansion here. So I'm going to leave it as 1 plus x, so all of that times by x, because we can see in our answer we kind of want all of that stuff times by x in a bracket anyway. So I feel like if I expand it, I'll probably end up putting it back in anyway. Times all this by minus 1, so that will equal minus 1 minus 2e to the power of minus 2. Okie dokes, let's keep going. So if it didn't ask us to show something, we could probably just leave it in this form and be done with it. But the 5th step is to do a load of rearranging. So e to the power of minus 2 is 1 over e squared. Yeah, just like if we had 2 to the power of minus 2, that is 1 over 2 squared. Yep, same thing applies. So let's put that in, because we can see in what they want. Ooh, that's cool. We can see in what they want, there's no minus powers of e, it's just e squareds. So that's kind of how we've changed that. 1 plus, that's 2 over e squared x minus 1 minus 2 over e squared. Okay, let's just have a peek at how they want it. They want y as the subject. Okay, so let's take this stuff to the other side. So y equals 2. Well, our amount of things with x in it, why have I put an x there, doesn't change, so that bracket stays the same. Now I've got minus 1 minus 2 over e squared. That's still that same stuff. Then I'm going to add ln 3, and I'm going to take away 1 over e squared. So minus 1, these two things can come together, can't they? So that's minus 3 over e squared plus ln 3. Let's just take another peek at what they want, because they've wanted it in quite an awkward way. So they want it as like 2 fractions over e squared and then plus ln 3. Okay, that's no problem. I know that 1, well, I can just write that as e squared over e squared. And similarly, minus 1 can be minus e squared over e squared. That's how I'm going to get that as a full fraction. So if I do that, I get e squared plus 2 over e squared. Yeah, because that would be e squared over e squared. Then you e squared plus 2, and then you keep the denominator the same. Minus, well, this is, I'll do this in 2 steps, because we've got an extra bit in here. We don't want to jump this too fast. Okay, they've got it with a minus in the middle there. We can see we've already got that. They want that with a minus in the middle there. So y equals to e squared plus 2 over e squared x minus brackets plus ln 3. We just want to put this in there, brackets now. Problem with this is when you took a minus sign outside, that means it divides everything out of these terms here, divides by minus 1. So this sign, when it comes in there, will change to a plus sign because you factorized out the minus. So that's e squared plus 3 all over e squared. If you got e squared minus 3, you've just made that small error there. So let's see if we got exactly what we wanted. Perfect. So yeah, take some time to absorb that in. Rewind the video if you need to. That's a pretty tricky rearranging, but I guess we can get questions like that. Okay, question 2. Okay, so we've been given something in the form x equals. Hopefully we know how to deal with that. Step 1, you just find dx by dy. Step 2, you flip to get dy over dx. I'll show exactly what that means in my solution. So that's part A done. Part B, this is where we need to do some, we're going to use a trig formula to substitute. And I'll do that obviously. We'll talk about that when we get to it. First of all, let's just do dx by dy. So if x equals to sec 4y, you just need to use your formula book. You are given this. You are told that if y equals to sec kx, then dy by dx equals to k sec k x tan k x. The same applies here with even if the x's and y's are flipped, they just give it you in that form. So it's going to be k is 4, so 4 sec 4y in this case, not 4x, and then tan 4y. That's dx by dy. To do dy by dx, you flip it. So this is essentially over 1, isn't it? So let's call it 1 over 4 sec 4y tan 4y. You could be tempted to think, well, I know that 1 over sec equals to 1 over 1 over cos, so I can call that cos. You could do that if you want to. You can have this as a quarter cos 4y cot 4y, because that would be what tan would be flipped. But then if you look at the solution of what they want in the second part, you can see that they kind of want a fraction in there with something over like an x and an x squared, like two things. So leaving it like this for your next step is going to be the best way of getting it to that second step. So although that may be helpful at some points, it's not going to be helpful in this case. And another reason why that's not going to be helpful, we'll see with the substitution, they gave us an x value, x equals to 4 sec 4y. So I can replace that with an x later on. If I put it into this form, I can't. Or I end up getting more complicated stuff like, well, cos is 1 over x and stuff, so it's a bit of a nightmare. So we're not going to do that. We're not going to put it into what I've put in red. So let's just leave it like that. So we know that x equals to sec 4y. So straight away, I could say that this equals to 4x tan 4y. Yeah? This. I can just do that. And I can already see I've achieved that x there. The awkward bit is about the tan. But we should know our trig identities. And hopefully we know that tan squared theta plus 1 is sec squared theta. We want something that has sec in there because we've been given a value for sec. So although you could say, well, tan is like sine over cos, there's no help to us because we haven't been given an x value for sine or cos. We just know an x value for sec. So you want something that links sec with the thing that you've got in your equation, in your dy by dx left. So if we want to be really explicit with it, we can say that, put the 4y in, theta just as a placeholder for anything that's the same thing. Take away the 1. And then square root it. So tan 4y equals the square root of sec 4y minus 1. But wait a second, we know that x equals to sec 4y. So sec squared 4y equals to x squared. So tan 4y equals to the square root of x squared minus 1. I would always do this as an aside, by the way. Yeah, keep your main line of working nice and neat, and then just do all these things off to the side. Don't cross them out though, because they're good pieces of work, but you could just draw a line down it like that. So let's keep it in blue. Dy by dx equals to 1 over 4x, and then tan 4y. Yeah, I'm just going to replace it with that square root x squared minus 1, which is exactly what they wanted. This value of k, a bit weird, that k is on the top, but the value of k is a quarter. So k equals a quarter. I don't know if they wanted you to state that. Yeah. There's no harm in doing it, is there? So there we go. Ignore the k that I've written there in the circle. That's what we get to. And then that's our value of k. Okay, so that's question 2. Question, move you away, question 4, we don't want you yet. This is question 3. Woo! This is question 3. Okay, I know we've just learnt about implicit differentiation, which you might think, could we use it on this? Yeah, probably. You could probably use it on this now, but at the time of handing you this homework, you did not know anything about it. And to be honest, there's no need to do implicit differentiation on this because we can just say, well, if that is this, why don't we just divide by 2x and get 4x over 2x equals y. And we can do quotient rule. If you wanted to retry it with some implicit differentiation, knock yourself out, see if you get the same answer as me. But that's what we're going to do. So if y equals to 4 to the power of x over 2x, well then I'm going to do some quotient rule. So u equals to 4x. U always equals the first thing you see, whether that's in a product rule or a quotient rule. The first thing you read, I read that as 4 to the power of x over 2x. So I'm going to say that, put that as u. And v is always the second thing you read. It's in alphabetical order. L, M, N, O, P, Q, R, S, T, U, V. So it follows alphabetical order in the way you read it. Differentiate. And differentiate. This one's dead easy too. This one, I'll do it as a... Yeah. Shall I do it as a full chain rule? Or shall I just say look in the book? No, I'm just going to say look back in your book at chain rule. There's an example of why that is that. But it gets you 4 to the power of x ln 4. So, a bit of an additional work. Look back in your book if you're not quite sure why that is. Or just see if you can remember the pattern. It gets about, it's a bit different as well when it's like 4 to the power of 2x or something. So have a look at that. It's good. It's interesting. And then quotient rule, we do this first. Yeah. So v times by du. And then second, we do that. We take them away. So 2, 4x. And then we divide it by v squared. So this in fact gets me that dy by dx equals to 2x 4 to the power of x ln 4 minus blah 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 blah. There we go. Find the exact value of dy by dx at the point C with coordinate 2, 4. Well, you could simplify that down if you really fancied it. You could even write that as like 2 to the power of 2x and then 2 to the power of 2x plus 1, but there's really no point. Just go straight into substituting some stuff in. If you've not been asked to show something is in a certain form, there is no point wasting your time rearranging when you can just substitute a value in and get it down to a number ASAP. So let's just go and sub x equals 2. Yeah, not going to waste any time with rearranging because it gets you no more marks and it's probably going to make you make a mistake. So it says an exact value, so avoid launching it into your calculator and maybe do a little bit by hand. So 2x is 4, 4 to the power of 2 is 16 ln 4 minus 2, that dot means times by the way, dot equals times, and 16 4 squared. Okay, so 64 ln 4 minus 32 all over 16. So that is 4 ln 4 minus 2. Perfect. Done. That is question 3. That's all it was asking. I mean, you could go ahead and you could easily find a gradient, equation of a tangent from there. You've got a point and a gradient. You could do anything else for an extra mark or 2 on there, but that's all it asked you to do. Okay, and then final one. Question 4. Parametric equations, lovely. So, a bit of a refresher on how we do our parametric equations. So, if we know that x equals to cos 2y, y equals to sine t, we differentiate both with respect to t first, so that will be minus 2 sine 2t. Oops, not by dx, by dt. Make sure your notation is correct. And there you go. If you were very vigilant, you'll have noticed that I did some wrong notation on the parametrics equation video for last Monday. I didn't use theta, I used y, or x or something, or t. Yeah, they were giving it in thetas, and I theta's here, and I put it as dx over dt, but it was x over d theta. If you noticed that, if not, go back and watch it again. Probably don't, it's not very interesting. And then to find dy by dx, we do dy by dt divided by dx by dt. The reason for that is keep, change, flip business. Ooh, look, they cancel each other out. Magical. Yep, so that's the reason why we do it. So cos t divided by minus sine 2t. It would be a lovely question if that was the final answer, but it says leave it in a single trigonometric ratio. So you are needing to remember your double angle formulas. The one for this one specifically. So sine 2t equals to 2 sine t cos t, if I'm not mistaken. Is that what I've got written down? Yes. Okay, so we can simplify that to cos t minus 2, then 2 sine t cos t. The cos t's now cancel out. So I get 1 over minus 4 sine t. I guess you could leave it like that, or you could put minus 1/4 cosec t if you really fancied it. Both are fine. Probably easier to leave it as sine, because on the second question we're going to do some substitution, and our calculator has sine, it does not have cosec. Yep, so let's just go from there. So that's part A done. In fact, I'll just do B along the side down here, so it's all on one screen. So find the equation of the normal. Remember, normal is perpendicular. That was fun. Is perpendicular. So first let's find the gradient. So find m at, oh, yeah, we can find that straight away. At t equals to minus 5 pi over 6. So take our dy by dx, which is minus 1 over 4 sine t, and if I substitute that in, it gets me a half, which is lovely. So then, well, that's the tangent. So the normal gradient, I can put it as that m, perpendicular. That's a little sign for perpendicular. We know it's going to be minus 2. So that's one piece of information. the other problem is we actually need an x and a y value to then find this. So we need to find a x and y value. We do that by putting it into these things. Yep, so if we put the t value into those, I get x equals a half, y equals minus a half. So now we can do y minus y1. So y plus a half equals to m x minus a half. Got that written there. So y equals to minus 2x plus 1 minus a half. So I've just expanded the bracket, then took away the half. There you go, y equals to minus 2x plus a half. So we get something out of that. It's quite cool, we get something out of like the cos sine business, and then the normal to that is just a nice straight line, which is pretty cool. That parametric equation probably represents a circle or like an ellipse, which is like a bit of a squished circle, because cos t sine t would represent the most basic like unit circle. Cos 2t is probably a bit stretched in the x direction, so it's probably a little bit like that, possibly. Don't quote me on that, not 100% certain. It could be the other way around, it could be smushed in the middle, so it could look a little bit like that, a little bit tall. But yeah, essentially we found that the gradient of the tangent is a half. We know the tangent to a circle is always a straight line, so then the normal is like that. So that's essentially what we found. But that's question 4. So thanks for watching.